All right, hello ATM. This is going to be a video on lesson 4-7. I was going to do two separate videos, one for the class portion and one for the group portion, but the class portion is extremely short, so I'm just putting it all together in one lesson, and it should still go by pretty quickly. So remember those video lesson tips that I showed the first couple of times. Take notes just like you would in class. Have all your materials with you. We will be using the graphing calculator again today, and pause it when you need to. If you have any questions when we're done, feel free to ask questions in Google Classroom or through email. Okay, as we've talked about in class, this author is a little bit interesting. He talks here in the paragraph about not having legal rights to call this angry birds. So he's calling them irate ducks. So he's got some ducks here that are very angry. And he's asking us to draw a flight path. So it says draw 4 flight paths, one from the duck cannon on the left to each of the beavers on the right. Keep in mind that gravity exists. It's not possible to fly in a straight line path, and birds can't fly through wooden posts. So we have to sort of show that we are launching from the cannon here. We are launching to get to the beaver here. We are then launching to get to this beaver here. We are then launching to get to this beaver here, and I have to go a little bit higher to be able to go over that last post to be able to get to that beaver there, okay? So that's all that he wanted us to do for number 1, was just to draw the pictures. If you've ever done the game Angry Birds, that's essentially what he's talking about here, but he legally cannot call it Angry Birds, so he's calling it irate ducks. Okay. It says, describe the shape of each path in your own words. How are they similar? How are they different? Okay. From my pictures that I just drew, we can see that, I guess the best description is that they form sort of an arc, right? But they're all different sizes and steepness. They are all arcs, but different sizes. And steepness. Okay. It says the shape of the path that an object moving through the air under the influence of gravity follows is called a parabola. This is something you learned way back in Algebra 1 and studied again in Algebra 2. This is illustrated in the time-lapse photo of a bouncing ball. Parabolas have several distinguishing features, but the two most obvious are the change of direction when reaching a high, or in some cases a low point, and the fact that two halves on either side of the direction change are mirror images. This is known as symmetry. So what he's talking about is here it's going up and here it's going down. That's one of the distinguishing features. And then I can also draw a line through the center showing the symmetrical image on the left and the right side. So then it says for number 3, the amount of profit that a company makes when they produce X units of a product can often be represented by a parabola similar to the one in the photo. Of course, if a company makes no product, they'll lose money. Explain why a parabola is a good choice to model the profit, okay? You have to think about maybe this being the x-axis here, okay? If they don't make any product, they have some sort of cost included in their company. We've talked about this in class, so they would be losing money. But as they make more product, they make more money, okay? So I'm gonna write as more units are produced, they can sell more and make more money. But notice the parabola goes down. So why does their profit go down? Okay, I'm going to say, but eventually they will produce more than they can sell. And production costs, how much it takes to actually produce the items, will eat up the profits. If they keep increasing the amount of material that they're making, whatever product it is that they're trying to sell, they're not gonna be able to sell as much as they're making. So at some point, you reach sort of a peak of how many product items you can make and how much your profit is going to be. And you don't wanna go past that. If you make too much product, you won't be able to sell it all. So that's something that you wanna keep in mind when you've got a business like that. Okay, so that is actually the class portion, believe it or not. That's why I said it's super short. That took me 5 or 6 minutes to get through. So we're gonna move forward into the group portion. All right, so it says a homeowner is planning to fence in a play area for his dog Moose, and he decides that he'd like to spend no more than the cost of 160 feet of fence. But since he wants Moose to have plenty of room for chasing squirrels, he decides to use the full 160 feet. He also wants the play area to be rectangular, as shown in the diagram. And now we're going to answer these questions. If he decides to make the play area 5 feet wide, how long would it be? So in other words, the width here would be equal to 5. I'm going to write it lightly though, because they ask us multiple questions, so I'm going to erase and go back. We want to know, what will the length be on the top and the bottom if the width is 5 feet? Remembering that we have a full amount of 160 feet. So I'm going to take the 160 and subtract the 2 5s. 5 times 2, okay? And 5 times 2 is 10, right? The 2 widths equal 10. So that gives me 150 feet of fence left, right? But I want to split that between the top and the bottom. So if I divide that by 2, that gets me 75 feet for the length. I know it says that these should be in full sentences, but to keep my video short as possible, I'm not going to write full sentences. All right, so then it says, what would the length be if the play area is 50 feet wide? So I'm going to erase my 5s, and I'm going to write 50 here, okay? So again, I'm going to take the total amount of fence. I'm going to subtract the 50 for both sides to find out how much fence is left. So 50 times 2 is 100. That leaves me with 60 feet left, and I have to divide that between the top and the bottom. So if I divide that by 2, that means that my length is 30 feet. Okay, I hope that math makes sense. At this point, I would ask if there are any questions and if I need to explain that differently, but just make sure you post your questions in Google Classroom, okay? All right, so then it says complete the table, then plot the points. Your ordered pair should look like width, comma, area. So notice the X value is the width, the area of the rectangle or square is going to be our Y value. So our ordered pairs are going to be W, comma, A. Now we found the length on the previous page for a width of 5. We found that that was 75 feet. We also found the length of 50 over here, and that was 30, okay? I'm not gonna do the math live here. I'm just gonna fill in the table based on the answers that I previously found. But let me at least finish the row for the ones that we know, okay? If the width is 5 and the length is 75, to find the area, I just do width times length. So I'm gonna do 5 times 75, and that gets me 375 for the area. Now what I'm going to plot on the graph is W, comma, A. So the width, comma, the area. So 5, comma, 375. Okay? And then I'm going to do that for down here as well. If I multiply 50 times 30, that gets me 1,500 for the area. And so if the width is 50, the area is 1,500. Okay? I'm going to go ahead and fill in the rest of the table, but again, I would like for you to do at least one row by yourself to make sure that you get the right answer. So maybe pause the video and see if you get it right. All right, now for my graph, this corner is obviously going to be 0, which is actually going to be one of my points. And then I'm going to go by tens here. Okay, that seems to be high enough. And then I'm going to go by 200s for the area. Okay, and let me plot these points as quickly as I can here. Doesn't have to be perfect, but you want it to be as accurate as possible. What I'm hoping you guys noticed is as you were filling in the table with me, notice the area goes all the way up to 1600, the one that I'm plotting right now, but then the points start to go down from there. So as you make the width of the fence bigger and bigger and bigger, the area eventually starts to get smaller. Just like that, okay? So we've filled in the table and we've plotted the points. We can see that it makes a parabola shape. So now we're gonna answer some follow-up questions about it, okay? All right, I'm going to keep that graph handy here. It says, based on the graph, what width makes the area as large as possible? So the largest area that we found was 1600, and the width that made that possible was 40 feet. So I'm going to write here 40 feet. That was the width that made the largest area possible. Again, I'm not going to write full sentences just to keep this as short as possible. All right, what's the area of the largest possible pen he can make out of 160 feet of fence? Okay, the largest possible area was 1600. If he used the 40 feet, the largest possible area was 1600. Okay, and that's feet squared. Okay. Describe the shape that the play area should be to make the area as big as possible. So if we're looking at this large one here, in fact, I'm going to circle it to kind of highlight it, okay? This is what he ultimately wants to build because it gives his dog the most area to run around, okay? And if we're looking at the width and the length, what kind of shape is that? Well, because the width and the length are the same, it's no longer a rectangle, it's actually a square, okay? So I'm going to write square here, okay? All right, let's move on to the next question. Write an explanation of the process used to calculate the need or the length needed for length and width. What we did, they're basically asking us to explain the math that we did here. Explain the math that we did here, okay? What sort of math are we using to be able to find the length needed for each width? So first we subtracted, so subtract twice the width from 160 feet. Then we divided that, then divide by 2 to get the length. Okay, that's the math that we did to find what the length needed to be if we were given the width. Now it wants us to take that sentence and turn it into an algebraic expression. Write an expression with W representing the width to describe the length when the width is W feet. Your answer to question 7 should help, okay? So we start with 160, right? And we subtracted twice the width from that. So I'm going to subtract twice the width. Then we divided that by 2, and that gave us the length, okay? I'm going to say length equals that. Now this can be divided. You might remember in Algebra 1 and Algebra 2, you learned that if you've got an expression where you have 2 pieces on top and 1 piece on the bottom, if they can all 3 be divided by the same thing, you should divide it. So that means my length is 80 minus W, okay? 160 divided by 2 is 80, 2 divided by 2 is 1, which I don't have to write it, okay? Now, number 9 says, write the formula for the area of a rectangle. That's length times width. Okay. Number 10, substitute your expression from the length in question 8. So take this and replace it with the area formula from number 9. Okay, so we're going to replace that. So now our area formula is not just length times width, but it's 80 minus W times W. So I took the 80 minus W and I replaced the L with it. Okay, and then this W stays the same. Okay, so this is a formula that I can use to find the area instead of having to calculate every single row over and over and over again. Instead of having to do all this math, what I could have done is simply just use this formula, okay? So let's move on to the next set of questions. All right, the profit made by a company that manufactures wind turbines is illustrated by the following graph. The first coordinates represent the monthly number of kilowatt hours of electricity generated by their turbines in millions. We'll use the letter X to represent this variable quantity. The second coordinates of points are the company's profits in dollars. Okay, answer each question with a complete sentence. Again, I'm just going to write the answers to save some time. What is the y-intercept of the graph and what does it tell us? Remember, the y-intercept is on the y-axis. It appears to be right about there. Okay, it's kind of hard to estimate. This would be about 75, negative 75,000. So I'm going to estimate that this is maybe negative 60. It's a little hard to tell. It is an estimate. Okay, the y-intercept of the graph is negative 60,000. This means that if they generate no electricity, the company loses $60,000. Okay, 0, negative 60,000. If they generate no electricity, the company loses $60,000. Okay, next question. Same directions at the top, so we don't have to reread that. What are the x-intercepts of the graph? Well, the x-intercept is where we cross the x-axis this time, not the y-axis. So I'm about here and about here, okay? Again, it's estimating. It's kind of hard to tell. I think they're going by tens here, so this would be 10, 20, 30. So it's about right in the middle of 20 and 30. So I'm going to estimate 25, 0. And then the other one, I believe this is 400, so 410, 420, maybe about 425. Okay, what do they tell us? Remember, the X is the amount of electricity, the Y is the profit. So we can say if 25, and remember this is in terms of millions, if 25 million and 425 million kilowatt hours are generated, the company will have a profit of 0, right? And we usually call that break even. That means their cost and their revenue are exactly the same. Okay, the company will break even. Their profit will be 0. Okay, next question. We're almost done. How much electricity would need to be generated in order to make a profit of 100,000? So 100,000 is right about here and here. Okay, my estimate of those ordered pairs is approximately 70 and 380. Okay, so this means about 70 million or 380 million kilowatt hours generated will make a profit of 100,000. Okay. I know I said for the questions I wouldn't be writing a full sentence, but I think just writing the ordered pairs doesn't really help us understand what the ordered pairs mean. So I'm writing the full sentence so you guys understand. 70 million kilowatt of hours makes 100,000, but so does 380 million kilowatt hours. That also makes $100,000. Okay. Number 14, what is the maximum profit the business can earn? Maximum profit is always right at the peak. It's kind of hard to tell. I'm guessing it's right around there. And my estimate was right at about 240,000. Okay. I'm just going to simply write 240,000 here. Okay, $240,000. Okay. That's the max profit the business can earn. How much electricity needs to be generated to reach that profit? I estimate, if I kind of follow it down, right about in the middle. So I'm going to say 225 million kilowatt. Okay, hopefully those answers make sense based on the maximum profit, the peak of the parabola. All right, now we go to our calculator. It says the function that describes the profit made by the company is this. So they finally give us an equation to work with. So go to your y equals and type in that equation, negative 6x squared plus 2700x minus 63,750. Go to your window then and put in these numbers for your window. Go ahead and pause the video if you need to. And then we can go ahead and press graph and we can see the shape that it makes. And it looks very similar to the one that they had printed us on the graph. Okay, so that's all they wanted us to do for 15 was just to graph it on the calculator. All right. Actually, let me go back. I think it did say, yeah, use the trace or table feature to verify your answer. So if I press trace, I can kind of play around with it and see that the highest that we possibly go, I think this is as high as I can get right here, 23,986, and that's about what we said. We said it would be 240,000, and my calculator is saying 239,986. If I wanted to do a more accurate procedure, I could do second trace and go to calculate. This you hopefully did in Algebra 2. Go left bound, go right bound, guess in the middle, and it does verify 24,000. Or sorry, 240,000. Okay. All right, moving on. This is the last question. All right. It describes what a quadratic function is. A function is quadratic if it can be written in this form where you've got an x squared piece. Okay. Notice that in a quadratic function, a cannot be 0. If the a were 0, this part would disappear, and then it would no longer be quadratic. It would be mx plus b. The letters are of course different, but b can be 0 because the squared would stay. This part would just disappear, so that's okay. So now number 16, it says, which of the following functions is quadratic? I'm going to circle a because it has a squared there, and the squared is the largest exponent. If I have an exponent larger than 2, it's not quadratic. It's going to be called something else. I'm going to circle b because, again, I have a squared. It's not in standard form. It's not in the right order, but that's okay. I'm going to cross out c because they have an exponent of 3. That's actually called a cubic graph. Now part D, I don't see a squared, but be careful. If you were to distribute to get rid of the parentheses, you'd end up with 2x squared minus 8x, and there is your squared. So we also want to include D. I'm going to cross out E because it has a square root function, and that's what causes it to not be quadratic. That graph looks very different than a parabola. Okay, and that's the end of this lesson. Sorry guys, I know 25 minutes, that was a long time, but it would have been silly for me to split the video into 2 sections. So I hope that makes sense on quadratic functions. Again, if you have questions on parabolas or quadratic functions, please put the questions in Google Classroom, or you can email me with any questions. Thanks for watching, guys. We'll see you next time.